Welcome to C Programming. In today's lesson, we're going to talk about structure. So what is a structure? A structure is basically a structure that contains multiple variables. So we define a structure with multiple variables with different data types, and we basically create, in a sense, like a plan of a house to build a house. So let's say, for instance, this house plan defines 2 walls, a door and a window. So 2 walls is 2 variables, a window is another variable with a different data type, and a window with a variable with a different data type. Now this plan contains those 4 variables or 5 variables, and what we can do is we can replicate and duplicate this plan to multiple houses, for instance. So we can take the same house plan and duplicate and build 3 or 4 houses with the same amount of walls, doors and windows. So a structure is basically a structure that can contain multiple variables and that encapsulates multiple variables into one name, so that we can more effectively work with a group of variables. Let's say, for instance, a student at a university. Now a student at a university has a name, it's got a student number and maybe a cell phone number. So what do we need to store? We need to store the student name, we need to store the student number and the student's cell phone number, and maybe the student's age. So what we can do is we can take that 4 variables and put it into a structure and call that structure student. And student is now like a new data type that contains 4 variables that we can initialize. So student has a name, it's got a student number, it's got a cell phone number, and it's got a age or a sex, male or female. So let's jump into the programming from the get-go and see how we can use structure. How do we define them? How do we initialize those variables inside that structure? And how do we use it in normal practice? Great, so let's jump into programming. So let's create a new empty file, and let's save this as, let's call this structures. Great, structures.c, and we save it. So first of all, we will start by hash include stdio.h int main void return 0. So we've got our main template. We build and run first just to make sure that everything works perfectly, and we check yes, it compiled, and we can continue now. Great, so let's start defining a structure. So where do we define a structure? Now the most common place to define a structure is before our function prototypes. So actually between our function prototypes and the libraries that we include. So we don't have function prototypes now, but after our libraries. So we will define our structures there. So first things first, or I just want to add your libraries and your defines, your constants that you define after that. Great. So we will define a structure, and we call it struct, and you will see it will be highlighted as dark blue. That's because it's a protected name. So struct is for structures, and this structure we will call student. Great. Now inside the structure, we start off with a curly bracket, open curly bracket and a close curly bracket, and never ever forget your semicolon. Now in code blocks it creates everything for you so that you don't forget it. So if I quickly take this away again and I begin with student or struct student and I create that curly bracket, the first one, it creates the close curly bracket and the semicolon for me automatically. Great. So what do we want to do in the struct? We want to create a student. So let's say a student has a name, and a name is a char variable. So let's char array, sorry, a char array. So let's store or create a char array of 5, or let's make it 10. 5-letter name is a little bit short. So char name, a student has a name, a student has a student number, okay, and student age, let's say age, and char for sex, male or female. So we're going to store M or F or other. Okay, male, female, or other. So name, student number, age, and sex. Okay, so our student struct contains 4 variables. Char name, that's an array, int student number, int age, and char sex. So inside that struct student, we've got 4 variables, and we can work directly with that variables by using only the name student. So how do we go declare a variable of type student? Okay, so first things first, just a disclaimer. This is now like a data type of data types. So this is a data type. Struct student is a data type that contains 4 data types. Okay, so what you need to remember is you cannot go and initialize. Please do not do that. We need to initialize when we declare it in C program. Please don't initialize there. This is just the plan. Okay, so we need to go and create a variable of type struct student, and what we can say is student1. So student1 is of type struct student. Just want to make sure. Yes. So as you can see, this becomes a little bit tedious to write out struct student the whole time, because now we just want to have one word for this data type. So what's nice is what we can do is we can type def this struct student to student. Okay, and how do we do this? So there's 2 ways of doing this. The first one is doing it afterwards, and we can just say type def struct student and make it student. So now student becomes the full data type. Okay, so student is actually struct student, and student is then all this. So we can just say student like that. So student, student1. Okay, but there's another way of doing this as well. What we can do is, let's take away that. What we can also do is we can type def from the beginning. We can take this out and we say type def struct, and afterwards we say student. And that's exactly the same as doing it here. So there's multiple ways. You can say struct student and you can work with struct student throughout your program, or you can type def the struct to a name that you want to use, and it's going to work exactly like int and char. So student is like a data type. So let's keep it as our beginning or our first example. We say struct student and we type def it here. So what I will do is I'm going to do two for you. We're going to say struct student and we're going to say student 2, and this will be in actual fact the same thing. Okay, student 2 will also have name, student number, age and a sex. Student 1 also a name, student number, age and a sex. So it's the same thing. So how do we actually give a declared student 1 structure? Okay, so this is the actual implementation of that structure. This is now like the house plan and this is the physical house. How do we initialize the name, the student number, age and sex? And it's actually quite easy. What we do is we say student dot name is equal to, let's say, Jacob. Jacob. And we say, there's another mistake. We need to say student 1. Well, let's make this a small letter just so that we keep track. Student 1. So what we can do is we can continue and we say student name, student number, and the student number is 1, 2, 3, 4. And the age is 20 years old, and the sex is male. We save this. And now what we can go and do is let's use a printf statement, and we can say student 1 name percentage s, and we can say student 1 dot name there, just like that. And we can continue with this and do the student number, and the student number is going to be D, and we can say student number, just make sure that we're spelling everything correctly, and then we can say student age, and age is also a integer, and then we need to do the last one, that's printf student 1 6, and that's percentage C, and that's student 1 dot 1.6. So let's see everything's spelled correctly. Yep, great stuff. So let's save this and see what happens. So there's an error assignment to expression with array type. Oops, so we can't do that. So what I will do is let's just keep it simple, and so we can't do that. So the easy way, this is now different syntax, this is C. So what we can do is we can use the printf statement, just like this, and we can print this into the name variable. So let's see if it works. Yes, I just want to add new lines before I show it. So what we can do is add new lines everywhere, and we can display our structure, and this is what we will see. Student 1 name is Jacob, student 1 student number is 1234, student 1 age is 20, student 1 sex is male. So there you have it. Now we can go and define structures that can contain different and multiple data types, variables, and we can type diff it to a certain name that we want to. And then lastly, this is what we call the dot operator. This here and this here, we use the dot operator. So we say student 1 dot age. What we can also do is we can create a student star. So it's going to be a pointer of type student. So I'm going to say PTR student 1, and student is the type, and this pointer is now pointer student 1, and it's going to be equal to the address of student 1. Oops, student 1. So this pointer student 1 is of type student pointer, and it's going to point to the structure student 1. Okay, so what we can do is, this is now the dot operator, but we also have the arrow operator. And how this works is we can say PTR student 1 arrow age is equal to 20, because this is now the address. Okay, so let's see if this works. So we've got the dot operator and we have the arrow operator, and yes, you can see we've stored 20 successfully. Now the arrow operator and the dot operator does the same thing. Okay, it's just used differently. So now you know that the pointer student 1 is now pointing to student 1, and it's actually storing the address of student 1. So that means that if we want to use the arrow operator on student 1, we can actually just reference student 1, and we can say point to 6. So if we run this, you will see it's exactly the same thing. And what we can also do is we can say PTR student 1 in brackets star. So we dereference the pointer student 1, we dereference it, and then we can use the dot operator. So there's multiple ways how we can interact with the data inside our structure. We can use the dot operator just by using it as simple as this, student1.name. We can have a pointer pointing towards that structure and dereference it, and then use the dot operator. We can use the pointer that's actually storing the address, and we can use the arrow operator, and we can also reference the student 1 and use the arrow operator. This is all the same thing to accomplish the same task. So that is structures. The basic idea is this is like a house plan. This is a wall, this is a window, this is a door, this is the roof. But remember, it's a plan. Here we actually go and create that house. Okay, and then we can start giving the wall a color, the roof a size, and so forth. So remember that we do not initialize here. This is our house plan, And here we actually create the house from the plan. So this is the plan and this is the house. Okay, so remember that analogy. Student is like a data type, for instance int or char, but it's not just a data type that contains a lot more. So it's one data type that contains 3 or 4 more data types. And that data types can be anything. It can be char, int, it can be an array, and there can be pointers in there. It can be anything. Okay, so that is structures, ladies and gentlemen. It's a very important topic, so please go through this video very carefully and try to understand this. It will be used in dynamic structure, so please make sure that you understand this, because this will enable you to understand dynamic structure much better. Thank you for watching, and I hope to see you soon.